Okay, let's take a look at the Henderson-Hasselbalch equation. You'll find this is a handy way to check the pH of a buffer solution. In a buffer solution, we have an equilibrium situation. And as such, it's really just another example of an equilibrium situation for which scientists have come up with an equilibrium constant expression. Concentration of the products over the reactants. Coefficients become exponents. Omit anything that's not in solution. And you've seen this before. So here's what it would be for a weak acid and its conjugate base. So it's a specific application of that. We can rearrange that mathematically, which you do not have to derive, and know that this is how we have what the situation is. I honestly don't know if this is on the green sheet for AP Chemistry, but you should see if it is. If it is, don't bother memorizing it, but if it is not, you need to memorize this. Not a bad idea to memorize it anyhow. Alright, so the pH is the pKa plus the log of A minus divided by HA for acids. There it is for bases. And what is pKa? It's simply the negative log of the Ka. If you look at this carefully, you'll realize that since this is a log-based system, each time this number right here, A minus divided by A, changes by a factor of 10, the pH will change by 1 unit. That's just a handy thing to know. We're going to solve a problem in a minute, but be aware that you do not have to derive it. Let's take a look at the specific AP Chemistry description of this. This is from the College Board. I'll read it in its entirety quickly. Computing the change in pH resulting from the addition of an acid or a base to a buffer is beyond the scope, so you should not see problems where they're adding an acid or a base to a buffer system. The reason is because algorithmic calculations of pH changes are not viewed as the best way to deepen understanding of the big ideas. That sounds like they just said, well, we didn't feel like it. The production of the Henderson-Hasselbalch equation by algebraic manipulations of the relevant equilibrium constant expression is also beyond the scope of this course and the AP exam. That's where they're saying it right there. So they're saying that derivation, check this out. Henderson-Hasselbalch equation is merely a rearrangement. Inclusion of its derivation is not the best way to deepen the understanding. So you don't have to be able to go mathematically from here to there. Hey, you could if you wanted to, but you don't need to. And you also do not have to compute this special kind of calculation there. Fine. What I like about this equation is that there's sometimes where it just is like tailor-made. Here's a question that works out well for it. You need to determine the pH. Ooh, pH equals. Perfect, right? Notice there's no pH in here, so you'd have to do it stepwise. And they give you the concentration of the weak acid as well as its conjugate base. That's what we need to plug in. This becomes a direct plug-in with one minor exception. Can you see it? They give you the Ka, but of course for this equation, we need the pKa. No big deal, just take the negative log of it. So we take the negative log of that number, and we add to it the log of that, and we're done. Two ways you can do this. Fast way, plug it all in, get a final answer. Good. If you're becoming experienced at that, do it that way. Second way you could do it is to break it into two pieces and write them both down, which I did here. The advantage of this is if you're double-checking your test, which you should, or your exam in May, you can check each little part of it and see where you might have screwed up. So that can be done either way, and that is the resulting pH. So it's handy for pH calculations.